Hey, welcome back to Deterministic. I'm Brandon Konkle, and on this channel I've been talking through Nest.js. It's a Node and TypeScript framework that I found has a really great balance of features and usability that makes it a strong choice to embrace TypeScript as a first-class citizen in your code when working within the Node ecosystem. But really all of this goes back to the title of my channel, Deterministic, determinism, the idea of being able to predict what's going to happen, knowing the inputs you'll be able to know the outputs. And that's really that strategy, that idea comes from functional programming. To kind of introduce why this makes things more deterministic, I'll talk first about object-oriented programming, the much more popular programming paradigm that really treats the problem of state, which really that's where a lot of our unpredictability comes from, is our handling of state, the way that we manage state, the way that we react to state. And so object-oriented programming uses encapsulation. They segregate state away into private classes that are responsible for these locked away pieces of state. And then you're using a lot of different object-oriented designs to interact between those classes in really predictable, well-patterned ways. With functional programming, the idea is to, instead of trying to carefully encapsulate and manage state, instead, you try to push state out as far as you can. So you keep your functional core pure. It's deterministic. It's predictable. You can determine the outputs based on the inputs. And you try to get that chaotic, mutable state out to as far to the edges as you can, so that your central code, your business logic, your control flow code, the framework code, all of that is as covered by pure static types as you can, and you've got a lot of good tests covering it and things like that. And then your more unpredictable kind of chaotic state, if it's pushed out to the edges of your system, it's easier to test it. You can test the internal components through units really thoroughly, and then test the whole system all together with integration testing in a really effective way. And so when you look at the more dynamically typed languages with less strictness, kind of the Node ecosystem by default, a lot of that chaos results in a huge emphasis on unit and integration and end-to-end testing. And I think those are all really great things. I think in a strict, sound functional environment, the need for those things is lessened. It's not as severe as the need is when you don't have those guardrails. But it doesn't go away entirely. But I will say, in the situations, in the experience that I've had with more object-oriented, more kind of mutable state, more chaotic systems, what I've found with it is that the tests aren't enough. The unit tests, the integration tests, the end-to-end test. You can spend 75% of your time writing tests for the 25% of code that you've implemented, and you still will run into unpredictable things in production that you just didn't think of at the time. So that's where this mathematical strict soundness comes into play. That's where the determinism really happens. And you see this with really strictly sound languages, like from the web community, Elm back in the day. Elm's claim to fame was that it could mathematically prove that you couldn't get runtime undefined behavior or runtime exceptions or null pointer exceptions, those kind of things. Those plague dynamic languages. And if you're in a sound, strict type system, you can use things like category theory to enable some pretty flexible abstractions that can be composed together interchangeably in really powerful ways. But the trade-off is that you're dealing with a whole lot of edge cases up front. The type system, the compiler, the checker really forces you to deal with things that may not be a practical problem in your application for real. And so the thing that I like about Nest.js, the framework that I've been talking about, is that it gives you tools to choose. You can pick which parts of your application you want to be really strict and really sound. You can embrace functional programming in a lot of ways to push that mutable state out to the edges. But then it gives you tools to put that together in a really cohesive and predictable way. And it gives you tools to test those things in a practical way. You can use the dependency injection system to maintain your strict type safety. Even in your test mocks, you can make sure that your mocks are always adhering to the signatures of the real things. but it gives you the tools to kind of work within the Node ecosystem to fudge things just a little bit, just in the right places, to help make all this work together really easily in a way that you and your teammates are able to kind of share and spread out. I think that the big power here comes from those abstractions, the middleware that Nest.js allows you to attach to different layers of the request flow. So we'll be talking about the authentication and authorization tools that I work with here, but the underlying it is one of those extension points that I've been talking about. That's going to be the guard system. So Nest.js guards, they come into play when you're about to invoke a controller method or a resolver method. So you're about to handle a request. You've determined, okay, what handler should be used? It's this one. All right, now let's check to make sure that the user has permission to take the action that they want to take. So the guard gives you a place to do that, to apply that permission checking code, and to annotate certain things on the request that you might need inside your method to communicate things like the username or the user ID, or in the case that we'll be talking about here, the ability object that allows you to make authorization decisions based on an entity or something like that. But the guard is one of those places where you can attach functionality to a specific point in the request lifecycle, and it makes sense. It's something that you can share among a bunch of different places. You can use it in REST controller methods and GraphQL resolver methods. You can share it with team members and talk about how it works. That's the power of what Nest.js gives you. So other types of middleware like this are interceptors, which are more like the classic middleware that you would see in Express, but you can shift the other way too, and you can wrap specific methods with things like the post middleware for REST requests that says, okay, this endpoint only handles a post request, so if it's another method, then don't handle it. Just little bits and pieces of repeated functionality that you just don't have to say over and over again in your code. It's a really great way to still keep things type safe, especially when you're talking about data access and GraphQL schema implementation and things like that. Like that can all stay really strict and type safe, and you're making sure that your data types are unifying with each other and things like that. But Nest gives you tools to make that easier. So, kind of recapping, here's the point of all this, here's where we're at. Let's talk about the specific topic of authentication and authorization. So this is a big loaded topic, and some people often get those two words mixed up. They conflate auth-in with auth-z. So when we talk about authentication, or when I talk about authentication anyway, I'm talking about identity. I'm talking about verifying who that person is because they've logged in and they've got a token that we only gave to that user. And so that's identifying the user confidently and making claims about that user's identity, like what role they may be a part of, or what their employee access ID might be, or something like that. Just different claims that you can make on the profile of that identity, or the payload of that JWT token, which we'll be talking about. That's what authentication is to me. And so JWT is really core to the modern strategies around authentication. You'll have usually an OAuth server, or maybe an OpenID server, especially if you're working with the identity server from Microsoft or something like that, that will allow you to go through a flow to issue a code or issue a challenge, something along those lines, that then allows you to exchange that for a JWT token that has all of the claims on it, like the account ID or the role or something like that, but in a way that's been signed by the identity server. So you know that this payload can't be tampered with because it's actually been encrypted from the server, and you have a way to reverse that encryption, but nobody could tamper with it. The moment that you try to change that payload, the encryption or the decryption no longer works. So you can be confident that this token, even though it's semi-public, it can potentially be passed around in different cases. There are cases where sometimes the user might find the token. That's okay because the token has been signed and it can't be tampered with. Contrast that with authorization, auth-z, and that's talking about, okay, now that we've identified who you are, let's figure out what you can do. So authorization is about making sure that the user has permission to perform the action that they want to perform. And even if there's no user, what can anonymous users do? Or it's figuring out what can users with this role do? And with Nest.js, you can perform this in a few different ways. There are really simple ways, easy ways to do this, and then there are some more sophisticated ways to do this. So I'm going to step into one of the more sophisticated ways, a way that I think will scale really well in large teams and give you ways to express really complex authorization logic, as long as it's based around some kind of entity, or if you want to create kind of conceptual entities via classes in your code, as long as you can relate it to some kind of data type that has attributes that you can create conditions based on, then you can use this tool to make those authorization decisions easy in your code. Relatively easy, I'll say. So, starting off, let's go ahead and talk about the authentication part of things, the JWT identification side of things. So I'm going to go ahead and bring my code editor into this. So let's pull up my VS Code window. I've got Castor, Nest.js. Oh, I don't have the README pulled up. I'll pull that up and show you a preview. This is what you'll see on GitHub, but if you haven't already run through all of these setup steps here, please do ahead of time and follow along in the repository if you want to. But I'll take you step by step through the identification and then the authorization tools that I'm using here. So for JWTs, first of all, like I said in my previous episodes, I've got my code organized into apps and libs. All the business logic, all the meat, all of the real things that happen in the code are organized by domain. So they're organized by the concern that particular lib manages. So I've got users, which also manages profiles, because profiles are intrinsically tied to users and the user ID or username, the subscriber ID on the token in our case. Shows also manages episodes, because shows and episodes are pretty tightly coupled. But you've got things like roles and authn and authz and events and utils that are broken out into their own domain. And so each of these packages, each of these libs, allows you to co-locate all the things that are needed for this particular concern, this particular domain of thought around your application. So for authentication, in my libs/authn folder, inside source, of course, the entry point to all this really is the guard. Now the guard is what I was talking about, the middleware that Nest.js provides to you that allows you to attach, share, or abstracted functionality, repeated functionality across a bunch of different places in your code. So this guard is intended to work with both REST requests and GraphQL requests. And it extends an existing guard here, you'll see. I am pulling in the Nest.js Passport library, and Passport is a relatively simple tool in the Node ecosystem, but it has a huge, just incredible array of plugins that allow it to work with just about every identification solution out there. So in my case, I'm pointing to auth0, and you'll see kind of the .env.example file that I have in the repo that kind of sets up some of my variables. You'll want to get those variables from your authentication source, whether that's auth0 or Okta or Cognito or your own server running locally or something like that. You want to plug this in with details for your source. But it's an auth guard that comes from, an auth guard that comes from the Nest.js Passport library. And you'll notice I'm passing this argument JWT to it. This is because I want this particular guard to extend the auth guard that is based on JWTs. So this is going to be a JWT-based guard. This uses this JWT strategy here. This is something that gets pulled in by all the Passport code, and this is where I'm configuring my connection details. This is where I'm setting my JWix server. JWix is the server that gives you all the cryptographic keys to verify that yes, your identity server is actually your identity server, and this token actually did come from it. And I'm setting it up for my environment here. I'm using this config tool, and I won't go into it in too much detail here, but basically config is based on Mozilla's Convict tool, Convict, I'm not sure how to pronounce it, but it's one of the great configuration tools out there that's really flexible. Config things via environment variables, JSON files, YAML files, whatever files you can think of, and override things in different ways. And it comes out with a TypeScript client that's really great. It gives you autocomplete, like I can say auth dot, and then it'll give me all the different auth things that I can reference in my config. So that's how I'm setting up my JWT strategy. That extends passport strategy, and then I'm passing it this strategy implementation from passport JWT. So all of this is put together in the module here. So in my auth-in module, which you'll see me import in the app module at the top level of our app, it is registering this default strategy of JWT. And that's essentially what pulls in this JWT strategy, which is identified with that JWT tag. Not on my own implementation here, but based on this passport strategy that I'm extending. That's where that JWT tag comes from. And saying, okay, that's basically the strategy that this auth guard is based on, JWTs. So a lot of that to just introduce how did we get here, what are we building on? But this can activate method right here is the key. So this can activate method, this is a Nest.js thing. This is how guards work. It gives you an execution context, and from that execution context, you can retrieve the REST request, or the GraphQL request, or the GraphQL generated context, or all kinds of different things about the request that's happening. And from that context, I first go ahead and call the super. So this is calling the method on the class that I'm extending. I'm extending authGuard, so this is calling canActivate on authGuard, passing it the context. The reason I'm doing that is because authGuard annotates the request.user property. And the request.user property is the JWT payload that was decoded on a successfully authenticated request. So I'm doing that first. I'm saying, okay, let's kick off this canActivate first. But you'll notice this is either a static value or a promise or an observable. It could be some kind of future. I'm not dealing with that yet. I'm going to deal with that in this next block down here because I don't know for sure if authGuard is using observables or promises, and they could switch at some point. They could say, you know what, observables are too much trouble. I'm going to switch to promises. All of a sudden, my extension point here would stop working in that case. So I make it work with both. I say, all right, let's check success. Let's see, is it an observable? If so, let's call to promise, which apparently is getting deprecated in a newer release. I'll have to figure out how to upgrade that. Otherwise, it is a promise or a regular value, so await it. Awaiting a plain Boolean won't hurt, but awaiting a promise Boolean will turn it into a plain Boolean. So then we have our success, yes or no. Now, I'm doing something here that kind of overrides the default behavior. The default authGuard here, it throws an error if there is no authentication token. If there's no JWT token in the request, then boom, it's throwing out a 401, it's done, cannot authenticate. I take a different approach. I like to specifically handle anonymous requests as something that's allowed, but doesn't have much permission to do very much. So when I catch the error here, I'm saying, okay, yes, you can return true, but you're not going to have a request.user property. That property is going to be gone because that was something that gets annotated by this authGuard and the default functionality that failed in this case. So I'm going to know request.user is blank, and I'm going to know to expect that in my authorization code. If it was not a success, then again, this is a case where it's saying, nope, doesn't have a valid authentication token. I'm like, yep, that's okay, so I'm going to return a true. But if we get to this point here, okay, if not success, we return true. So at this point, we know it was successful. That means we've got an authentication token to work with. Request.user exists. So step one, let's get the request. I am using a little get request helper here that takes both a REST request or a GraphQL request out of the execution context either way and gives you this JWT request, which is the request that I define in my auth-in types here to expect. So this JDBT request just has the JDBT annotated on it, but you'll notice I've got it on rec.jdbt, not rec.user. So that's what's happening down here. I'm saying, you know what? I want to use rec.user for something else. So I'm moving that property over to request.jdbt, and then I'm going to delete request.user because I'm going to use that in the authorization phase of things. Then I return true so that it doesn't throw a 401 and it allows the request to flow through to the controller. And I know that my controllers will expect maybe there's a user, maybe there's not. Whew, all right, so that's how authentication flows through. That's how you get to a point where you've got either a request.user or not. And then to pull it out, I've got this JDBT decorators here. These are just decorators that pull the request out using that tool. So whether it's REST or GraphQL, it doesn't care, and then determine some things about it. I separated the actual operations out into this auth.utils so that it can be used by things other than just decorators. But really the decorators are the chief consumers here. It's checking to see, okay, is authenticated, is checking to see, is there a rec.jdbt, and username is pulling the rec.sub. Where is it? Yeah, rec.jdbt.sub, which is the subscriber ID. And so these are what you use inside your resolvers to actually make use of all this stuff. So let's switch over to the shows resolver. And then you'll see I'm using decorators. Here's one, request user. I'm pulling request user in. And in this case, I'm telling it, you know what? I do want a user. If there's no user there, let's go ahead and throw a 401 in this case. That's part of the built-in functionality of that request user decorator there. Where to go? Where does the request user? It probably comes from the authorization package because it takes a little bit more into account. Yeah, because the authorization package is actually retrieving the user object from the database. We'll talk about that in a minute, but this is how you use those features. The auth-in guard is kind of a lower level piece that I build on top of with my auth-z. And so most of the decorators I'm using come from the auth-z package that's building on top of it. All right, so now you know how all this is working. Essentially, the strategy that it takes is it is negotiating with the JDBT, the identity server, at the point of this can activate, and it's checking with the server to see, or it's checking to make sure that this is a valid token that came from that server based on the JWIX keys that it's finding. It's decoding the payload and all of that. That all happens right here. And then the request flows through to the controllers. All right, so that was the identification piece of things. Let's move on to the authorization part. Let's move on to, okay, now that we know who we're dealing with, or if we're dealing with anyone at all, it could be an anonymous request, let's figure out how we decide what they can do. So Casl is the tool that I've talked about that I really like here that gives you, tools to build up authorization rules. It allows you to take an entity and create conditions on attributes or fields of that entity that help you say, okay, this user can access only these payments that have their account ID, for example, or something like that. Or if this user has the admin role, they can view everybody's payments, something along those lines. This helps you make those decisions. It doesn't manage the hierarchy of roles and permissions themselves. I'll talk about that towards the end of the video, but given that hierarchy that you manage typically in your database or maybe through an external service or something like that, given that hierarchy, you can then define rules with this and then check those rules with this. That's with the power that this brings. So let's share my window again. And let's talk about the Casl authorization piece. So we're going to close the auth-in window here, and we're going to pull up the auth-z folder in libs, yep, libs auth-z source. And the entry point here, once again, is this auth-z guard. Oh, and I neglected to show where the auth-in guard was actually used. I'm going to pull up that shows resolver again and backtrack and show here. useGuards is the decorator that Nest.js provides to allow you to apply one or more guards to either a class or even an individual method. So I'm saying the whole class here. First gets piped through the JWT guard, then it gets piped through the authz guard. So the authz guard is what I've got pulled up here, and it has a similar strategy to what we already looked at, but instead of extending something else, it implements an interface. This is the interface that Nest.js provides that enforces the signature of the canActivate method here. It makes sure that your canActivate does what canActivates are supposed to do in the Nest guard pattern. My canActivate, first off, uses a reflector. So this is a concept in Nest where at build time, you can set metadata for things like methods or classes or things like that, that configures behavior for that particular class or that particular method. So in our case, we're looking for the allow anonymous metadata. So allow anonymous is a way for me to now say, okay, now that I'm in this authz layer, I've allowed the authn layer, the authentication, the identity layer to flow through if there's no user. But now I want to be able to, where is it? Yeah, now I want to be able to, by default, reject those. I want to say, okay, by default, anonymous is not allowed, but you can decorate your functions or your methods with this allow anonymous decorator to say, okay, it's allowed for this method, not by default. It's secure by default, but explicitly you can say this method supports an anonymous call. So that's where this is happening. This allow anonymous decorator, we'll go into that. It's really simple though. It uses this set metadata helper that allows you to set that build time metadata at Nest.js. It's similar to how Spring allows all the annotations to implement the actual stitching together of things. This is the same kind of thing where you're setting the metadata as you're defining the code, and then it's consumed on the bootstrapping of the application, and that's how it wires everything in. In this case, it gives us the hook here, this get all and override method from the reflector. The reflector is a Nest.js term for something that lets you look into, you peer into the metadata that was created at build time and pull everything out that you want. So in our case, we're looking for a simple Boolean, which is provided by this allow anonymous metadata type. It's providing the type in the signature is really good for more complex things, but simple stuff like this, it's probably overkill, but I wanted to demonstrate best practices here. It's a Boolean. So then I define a little helper function here because I want to be able to use this in a few different places and I don't want to repeat myself. So I've got a nice little inline function here, a closure, if you will, that handles anything that's anonymous. So if allow anonymous is true, if we found through this metadata that this particular method that's being called right now is okay if there's no user, then what we'll do is set up kind of a default generic ability that doesn't have any permissions. So you'll see this ability factory has a create for user method that we'll talk about in a bit, and it can take nothing. So we're giving it nothing. We're saying there is no user, so give us a generic anonymous ability. The ability comes from the Casl package, and that's what gives you the permission checking methods. There's also a censor. So in a lot of cases, you will only want some data to be publicly available and some data to be available only to certain users like admins. So like somebody's email address might be something that you don't want public users to be able to see, and so you want to censor that field, but you do want admins to be able to see, and so Casl gives you a tool, a facility for encoding that intent, for allowing you to provide certain fields for certain users in certain cases, but then censor them otherwise. And so this is a utility that helps put that into play really easily. You can just use the censor decorator and you'll get your censor that you can then call on your retrieved entity that will automatically eliminate the fields that this particular user that's calling can't see. Whew! A lot of complex stuff going on in the world of authentication and authorization, but I think these tools that we've got here help make it a little easier to get a hold on and get a grasp of. All right, so we've got our handle anonymous routine defined. We pull our request from our get request utility, and we use one of those utilities to get the username, which is the user sub. It's the sub on the JWT token, which usually corresponds to your Auth0 ID or your Cognito ID or what have you. If there's no username here, then okay, let's go through the handle anonymous routine. Let's check to see if that allow anonymous metadata was set or not. If there is a username, then let's go on and let's try to find next an actual user. So this uses the user service that works with Prisma behind the scenes. I walked through how that worked last time. And it calls the get by username method with that username that we retrieved and optionally gets a user object with a related profile back. If there is one, then we're good. If there's not one, then we'll return that handle anonymous again, because yes, even though they had a username, they're not a valid user, so let's treat them as anonymous. All right, so if we've gotten this far, we know they've got a user. Let's annotate the user instance itself. So this is actually the user with the related profile data as an object that we attach now to the request so that we can pull out as a decorator for method params in our resolvers and our controllers. And then we also create that request.ability and request.sensor, this time passing the user that we retrieved in so that it can actually make decisions on what we found based on the user. Same with the sensor, it gets the ability that we just derived. So what is all this stuff doing? Where's that going? It is the auth-z, what is it? No, it's the ability factory. That's where it comes from. Yes, the ability factory is what we use to take a user object and apply all of the rules that we want this user to have, the things that they can actually change or see or delete or update, whatever you want. You can define it here with these can and cannot methods. Now these use some of the types that we're defining over here that are based on our Prisma models. They come from our Prisma client up here. And then there's also this Casl Prisma library that we're pulling in. And so this app ability and the can and cannots have those entities encoded in the types. And so they give you some autocomplete and some help about what fields that you can set conditions on. But you'll notice we're not actually doing any of that right here in the ability factory. We're just iterating over this enhancers thing. Now, the enhancer thing, that's my own thing. The idea is a rule enhancer takes these can and cannot tools and uses them to enhance the ability with whatever rules apply to this particular domain. So I'm decoupling things here. I'm saying, okay, the auth-z library here, it shouldn't know about all the different libraries, all the different entities in our app. It shouldn't know that there's a show and an episode. It shouldn't know anything about that because I might want to shift shows and episodes over to another service entirely. If I'm going down the microservices path, I might want to split things up entirely. I don't want this generic auth-z library to have inside knowledge about those things. Now, it will need to know about the user. The user and the profile are pretty closely tied to authorization, but everything else, the shows, the episodes, the topics that we'll create later on, those are decoupled. So how it does this is it uses these rule enhancers, and a rule enhancer is simply an interface, kind of like a trait or something like that, that defines this for user method that needs to be implemented. And the for user method takes a user and it takes those can and cannot methods that we were looking at. And then it returns a promise that doesn't actually return anything because it's all happening via side effect. So as you're calling can and cannot, the internal state that the ability is building up gets constructed. It's a builder pattern. So you're imperatively kind of building that up. But this way, we're at least saying that domains, libraries can control the rules for their own objects. So let's look at one of these and what it actually looks like. Let's take a look. Yeah, show rules I think is a good one because it demonstrates a couple of different things. So this implements that rule enhancer trait or the signature, the interface in TypeScript language that I've set up there. And it provides the for user method that takes that user optionally with the profile, and it could be it could not even exist. It could be undefined, we found. And then it makes some decisions about what they can do. So first off, all anonymous users can read a show. Everyone can read the show. This means, like, let's look at the show model. The show has a title, it has a summary, a picture, content, which is like a description field or something like that. This is all public information. This is fine for anyone to see. So any user can read a show. And then if there's no user object, let's stop there. We're done. We're not going to let anonymous users do any more things. So once we get to this point, we know the user is authenticated. They're positively identified as somebody. That means they're going to have a user object. And so we can then pull in, we can pull in things like the profile to make decisions. But first, you see the first thing that we do is we say, oh, you're logged in? Okay, you can create a show now. Anonymous users don't have a user ID to set up permissions for. So if they created a show, they couldn't do anything with it. So you've got to be logged in to create a show. It retrieves the profile ID from the user object. And if there is no profile, then we're done. They can create a show, but nothing else. But if they do have a profile, then let's look up all of the roles and permissions for this show that this user has. So we use the profile ID. Now, we're using the profile ID rather than the user ID because I want to provide for cases where a user wants to switch from one authentication provider like Google to another like Facebook or something like that. And so in that case, their user would change, but their profile would just move from that user over to the next user, and all of their roles and permissions would follow them to that new user. So in this case, we're looking up the show permissions by using the roles service here. Now, roles and permissions I'll talk about a little bit more towards the end of the video here. They're not too crazy, but essentially this service gets all the permissions for this particular show table based on this profile ID. So it's asking for a profile ID and a subject table, and our subject in this case is show. So we get all the permissions that they have for the show. This is a record that takes a string, or that has string keys. Of course, all objects in JavaScript have string keys. And then all the values have to be an array of permissions. So in this case, the string keys that it's taking, those are, you pull this up here, those, now I got to get roles for table. Yep, it's buried a little bit. But the string keys come from the subject ID. So this maps those group values and takes it from a role grant. Yep, this is getting deep into the roles code that I didn't want to show off yet. But essentially, each one of those string keys there are show IDs, since this is records that are coming out of the show table. That's something, looking at this now, I could do a little bit more to communicate to the user. I should probably make that an opaque type that says like subject ID instead of just a transparent string like that would communicate this a little better. All right, so we've got our permissions. We iterate over each of the show IDs, and then for each one, we iterate over the permissions for that particular show. And then we look, okay, what kind of permission is this? So in this case, all of our permissions come from this show roles. So you can see we have permissions like update, delete, manage episodes. So create, update, and delete any episode for this show. Or manage roles, create and revoke user roles for a particular show. And then we have roles. So the manager role gets the update and manage episodes permission. The admin role gets all of that plus delete and manage roles. And then we export a quick little index object that I use later on to stitch all these things together easily, separating the roles from the permissions like that. So we come back over here and we see, okay, let's see. Let's look at what type of permission this is. All right, if this is an update permission, then we're going to say they can perform the update action. So this is Casl parlance now. They can perform the update action on the show entity for any records that meet this condition. And the condition is ID must equal show ID. So if the ID of the show is the ID of the permission that's been granted that we're working on in this array here, if it's the update permission for this show ID, then we call can and we tell Casl, hey, they can update this show. Same with delete. We call them and say, okay, they can delete this show too. If they have the manage episodes key, we can say, all right, they can perform this action manage for episodes related to this show ID. So this is a case where we're taking the show ID and using it as a condition for the episode entity. And then finally here, if they have the manage roles key, then they can manage the role grant object, which is the database table behind the scenes that's managing all these. They can add or remove those for this particular show, this show ID. So you can get really granular with it. You can get really detailed row level permissions with this. And then when you go to use them, let's go look at the show's resolver here. When you go to use them, where's an ability? I've got to find a create show. Yep, this is a good one. So I'm using the decorator at ability. This ability decorator pulls in that request.ability property that you saw we were building up inside the authorization guard. So this app ability, that allows us to call, where is it? .cannot here. So in my case, I'm saying, first, make sure there's a profile ID. If they don't have a profile ID, then we can't tell whether they can create a show or not. So we're going to call it a bad request. User object didn't come with a profile. That's a problem. Then we call ability.cannot. So we say, if they're not able to create a show with these properties, so I'm taking the input and I'm casting it as the show object to give it a quick way to kind of pass those properties over. The most important one being the, being the ID. So right here it's saying, oh yeah, no, this is create. So for create, actually, we're not actually doing anything with the properties yet. So it's not important on this one. I'll skip over to the next one so that we can see, yeah, here's where we're using an existing one. So, all right, this is update show. This is a little bit more sophisticated in the check that it's doing. Again, it gets the ability, and then it says, okay, if they cannot update this particular show. So I'm taking my show that I got from my service, and I'm using the subject helper from Casl to tell Casl, hey, I know this isn't an instance of a class or anything because it came from Prisma, and Prisma just gives us plain old objects, but trust me, this is an instance of the show class. That's what we're telling Casl through this. So we're saying, okay, if they can't update this particular show, then throw a forbidden exception. That's a 403 error. And you can see that's based on the ID. That's based entirely on, did this get called? So do they have that permission with update for that show ID? If so, then this is going to evaluate to true, and it'll skip over the forbidden exception and go on to actually updating the show. So, yeah, this Casl tool actually gives you some really powerful tools for kind of preemptively checking too. If I wanted to say, all right, before I check about this particular show, let's see if they can update any shows at all. Maybe we want to just short circuit this and not even try to go down this path if they can't update any shows. What's the point? So in that case, I would say ability cannot update. And then instead of passing it the subject helper, I would just say show. Can they update? Whoops, I did not pass that correctly. That needs to be inside the parentheses. And then, my prettier is going rogue. All right, there we go. And let's throw the exception to get rid of that. All right, so this right here is saying, can they update any show at all? If there's any record within the show entity that they can update, then this will flow through. If there's no records within the show entity that they can update, then we'll throw the forbidden exception right off before we even go down the path of getting the existing show to check against. So that can increase performance in some cases if you want. There might be strategies that use that to optimize things. It was something that tripped me up at first because I didn't understand that was what it actually meant when you passed just the entity name and no object or no object to check against. So now seems like a pretty good time to go ahead and go into the roles and permissions that I was talking about. So you're seeing how we identify the user, how we set rules based on that user, and then how we check those rules to make authorization decisions inside the controllers or resolvers. My application is all GraphQL, so it's all resolvers. But if your app is REST, then you'll see controllers around too. But how am I setting up this hierarchy of roles and permissions? That's one thing, honestly, I was a little disappointed that the Casl library doesn't handle for you. I think there are some ways that it could handle it in a portable way so that I could ship it off to Prisma to store the actual data, but maybe it could handle the hierarchy, the checking logic, the logic of, okay, these permissions go with these roles. But it doesn't, and I understand that because it's really trying to remain agnostic. It's trying to work in a lot of different environments and a lot of different contexts. You can even use it with React on the front end with your components. So I love that flexibility. That's a good thing. So to manage those roles and permissions ourselves, what I do is create my own database table for it. And it's just one table, not a bunch of tables. The reason for that is it's a generic relationship. It's not an actual static relationship that I manage in this roles library here. So libs roles is pretty simple. It's just got the roles module, the service, and the types. So pulling up the types, we already saw a reference to this earlier. When we were defining permissions and we were defining roles, we used these types to make sure that we followed the right structure, that we're giving it what it expects. And these types allow you to set up your roles and permissions as a static thing. So what the roles are and what the permissions are isn't stored in the database. It's statically defined within the code. And that gives you a lot of power in some ways, but it also sacrifices some flexibility. If you wanted to expose this to an admin system and say, give people the ability to create their own roles that remix existing positions or permissions in different ways, then you'd want to move to actually storing it in the database. But in our case, we can do it statically because we don't want to change what the roles and permissions are without a deploy. We're okay with requiring a new deploy if we want to change what those roles and permissions are. And so instead, we keep it entirely within a role grant table. So let's go ahead and pull up the Prisma migration, or the Prisma schema, yeah. So this is the Prisma schema, and here is the role grant model that we're setting up. This is a table in the Postgres database, and it has a couple of things. It has a role key, and so this comes from the key of the role definition. I will pull up, where did my shows go? My shows are over here. So the show roles, the key, for example, is something like show manager, show manage roles. I'm using a constant style, all uppercase. What is it? They call it shouting snake case, which I love. So, but it's keys uniquely identifying the roles and permissions. And so in here, you've got the role key that's a string. Then I've got the profile, which is whatever the related profile that this role grant is for, based on the profile ID. So a role grant is always based on a profile. And like I said, that's on purpose, so the profile can move from user to user if they want to switch how they're logging in. That profile determines who has this role grant, who is this role granted to. And then the subject table and the subject ID are about what entity it is. So the subject table is going to be something like show or episode. It's going to be the tables that are created by the other entities in this Prisma schema. And the subject ID is going to be the particular row within that. It's going to be, the show ID or the episode ID, the particular entity that this role grant is for. So in the case of a show, we're saying this person, this profile, can only perform this role for this particular row in that table, this particular show ID or something like that. And so based on that, we can say, okay, this user has this role. And so then we go and look, all right, so they have the show manager role. What permissions does that give them? That gives them the update and the manage episodes permission. And so then in our Casl rules, where we're checking against what they can do, that's where we're pulling, I need to find the actual show rules again. There we go. That's where we're actually making use of this and pulling it down and saying, okay, for that show, they can do these things. So this generic relationship strategy is a little bit fragile because obviously subject table and subject ID are not referentially stable. They're not checked to make sure that if there's a drop, there's a cascade or something like that. That's a limitation. And so I work around that limitation somewhat with triggers. So I've tried a few different strategies. I've tried to work with checks and things like that to kind of bring some referential stability to these things. But the thing that I found that worked the best was triggers. That's a Postgres specific feature. So it's going to be different in your language of choice if it's not Postgres. But I'm using these triggers to check to see things like, okay, if a role grant is created, then let's check and make sure that subject table actually is a table. So we use the Postgres information schema to say, yep, subject table really is a table in this Postgres database. That's okay. And we do things like, all right, so if a profile is deleted, then delete all the role grants for that profile too. So the classic cascade. Things like that you have to do manually with a generic relationship because the database foreign key structure is not going to enforce it for you. And constraints are don't always take into account row IDs and things like that. The check constraint strategy I found didn't work very well for me in this case. But you will see that my roles live, not apps, my lives/roles service here gives you all of the things that you need to grant permissions. So it gives you tools to work with those statically defined permissions. It gives you tools to check the permissions to see, okay, what are the roles? Do they have this particular role? All of these methods are working with those static roles and permissions and the grants that you see in the database and helping you figure out who has what. All right, so all of this is ultimately wired in. This and the piece about the rules and bringing in the Casl rules, I mentioned they were wired in through the app module. So I'll pull that up here. This is where the magic happens. So the auth-z module here, this pulls in all of the role or all of the Casl authorization rules. So user rules gets imported from user rules and profile rules. They get imported from the user package. Shows and episodes get imported from the shows package, but they all get injected here. They all get provided, I guess, for the top level. So if you look at this auth-z module, the for root method is a global provider, or I guess a global module is the right terminology there, that provides all of the rules classes that we passed in, and then uses this, it provides the rules token. So this is rules. It comes from our auth-z types here, and this token is all the rules that have been initialized for the application that's currently running, based on this app module that was passed in here. And so that's where you get the rule enhancers that you can iterate over to apply these rules to your user. Or, I'm sorry, apply the rules to the ability that gets attached to the request object for the user. So complicated. All right, so then you've also got the roles module here that does the same kind of thing. You know, for root, it's a global module. It pulls in providers that give the permissions and roles all together. It's spreading them all into an array here, so it's a single array. Makes it kind of simple. That was the index object that I talked about before. And then, yeah, it's all wrapped up in this app module that gets instantiated when main.ts is run. And it also plays a role in testing, which we'll talk about in future episodes. So yeah. This is a lot. Authentication and authorization is a deep topic. I've barely scratched the surface, but I hope that you found the approach that I use to keep things maintainable across a large team might be helpful for you too. That the decoupling of the different layers that they have and the usage of this Casl tool that gives you kind of a shared language that you can share with the front end too, and help them develop tools for building out those components and showing and hiding things based on roles and things like that. It gives you a way to use the same tools, and sharing is great. That's one of the advantages of Node in general, that you can share things with the back end and the front end. But I think that's about it. That's all I can take today. I've covered enough complexity. Coming up next in our series, I believe I'm going to tackle unit and integration testing next, but before that, I'll probably throw in a bonus Rust episode. I've been getting up to speed with Rust. I've been trying to find a structure that works for me for GraphQL, and I've had some great learnings that I want to share, and hopefully you'll find them useful too. So watch out for that coming soon, and thank you very much for watching.